Right, so our three main rules that we're going to be quizzed on tomorrow are when two functions are multiplied by each other. That's going to be our product rule. For our product rule, it's not just derivative times derivative. You have to do derivative of the first one, leave the second one alone, plus leave this first one alone times derivative of the second one. So we usually just call it u prime v plus u v prime. Now for quotient rule, when you have two functions being divided by each other, this is where we do the low d high minus high d low. So low is v, d high would be u prime, minus high, d low would be v prime, over low squared, like that. And lastly, when we have a function inside of another function, this is going to be our chain rule. So we take derivative of the outside, v prime, leave the inside alone, times derivative of the inside, u prime over v, there's no v, u prime of x. Our trig functions, for sure, you can be guaranteed these are going to be on here. Derivative of sine is just cosine, derivative of cosine is negative sine, and derivative of tangent is secant squared. Derivative of secant is secant times tangent. Cosecant is similar to this one, but it's cosecant and cotangent, and the c's all have a negative when you take the derivative. And then cotangent is similar to tangent, so secant squared is actually cosecant squared in this case, and again negative for the c ones. Right, when we look at our unit circle, so at 0, your x value, because cosine is just x, your x value is 1. At pi, that's halfway through the circle. At pi, my x value would be negative 1. At pi over 2, that's 1/4, pi over 2. Your cosine, or your x value, would be 0, because you're on the axis. And at 3 pi over 2, down here, again, my x value is still 0, because I'm on the axis. Sine of 0, sine is your y value. At 0, your y value is 0. At pi, my y value is still 0, because I'm on the x-axis. And then at pi over 2, my y value is 1. And at 3 pi over 2, my y value is negative 1. Like this. For a horizontal tangent, so you find the question, or you get the question like, find all x values where f of x has a horizontal tangent line. A horizontal line has a slope of 0. And we know that the slope of the tangent line just comes from the derivative. So this would say your derivative equals 0, so that means find f prime of x and set it equal to 0. Whatever x values make this 0 is where we have a horizontal tangent line. To find the equation for a horizontal tangent line, you need to have the slope, which is just the derivative at that point. And you need to have a point, because you're going to plug into y minus y1 equals x minus x1 like this. And to find the point, that means just basically plug in, so you have x, y. So, finding the equation of the line tangent to the graph. So first step, I want to find my slope, so I'm going to do g prime of x. I'm going to rewrite g of x is 2. This is just x to the 3/4 power, because the fourth root is like dividing by 4 in the root. And this is on the bottom, so I'm going to bring it up with a negative, so this is x to the negative 3/4. Right, and then g prime, I'm going to take the derivative, bring this down, 2 times negative 3/4. Take away 1, that would become negative 7/4. I'll rewrite this, so 2 over 4 is just going to cross off and give me 2, so I've got negative 3 over 2, and then bring this down. Now I don't have the negative exponent anymore, and divide by 4, and the power is root 4 of x to the 7th, so g prime of x. And I don't want the function, right? I want specifically when x is 1, so I want g prime of 1. So it's just going to be negative 3 over 2, and then this is 1 to the 7th rooted. It's still just 1, so it's just negative 3/2. So your slope is negative 3/2 at this point. Now before we can plug into point slope form, I need to know the point. So let's find what g, just g, not g prime, g of 1 is. So g of 1 is 2 over, again, the 1 to this power, which is just 2. So then your point is 1, 2. I've got my slope, I've got my point, plug in. Y minus y equals slope, x minus the x value. That's your answer. Here we are looking for where it has a horizontal tangent line. That tells me set f prime of x equal to 0. So I find my f prime. That's going to be 4x cubed minus 16x. Derivative of 2 goes away. Set this equal to 0. And now I want a factor to find because there's multiple x values that make this 0. So I'm going to pull out an 4x. That leaves me with x squared minus 4. That's 4x, x minus 2, x plus 2 that equals 0. So then each of these factors can make it 0. So for this one, that would just be x equals 0. For here, that would be positive 2. And for this one, that would be negative 2. So those are all the x values. Derivative of secant. So this is going to be chain rule. So derivative just of the outside, derivative of secant is secant tangent. Leave the inside alone. Sorry, not equals, this is f prime that would be equal, taking the derivative, times derivative of the inside. So derivative of the outside, leave the inside alone, times derivative of the inside, which would be 16x cubed. So I'll rewrite this, f prime of x is 16x cubed, secant of 4x squared, tangent of 4x squared. Not 4x squared, that's 4x squared. The next one, so I'm going to rewrite this one as sine of x to the 5th. All to the cubed, or the third power. This is going to be a chain rule because I have this outside function, the cubed, an inside function sine, and another inside function, the x to the 5th. So I'm going to have to do it twice. So first things first, the 3, this is sine of x to the 5th, now to the second power because I take away 1, times derivative of the inside. Derivative of sine of x to the 5th would be cosine of x to the 5th. And then I have one more inside, derivative of x to the 5th would be 5x to the 4th. So then that can be just cleaned up a little bit to 15x to the 4th sine squared of x to the 5th times cosine of x to the 5th. And that is my f prime. Square root of theta plus sine of theta. So theta is like my x here, right, what I'm taking the derivative with respect to. So I'm going to rewrite this as just theta to the 1/2 plus sine of theta. So taking the derivative is easy, 1/2, theta to the negative 1/2. Derivative plus derivative of sine is just cosine theta. And then this is correct, but I'm going to rewrite this because this is to the negative 1/2 power. 1/2 means square root, and negative means put it on the bottom. So that's 1/2 root theta plus cosine. So this is my g prime of theta. D is another that has a function inside of a function, so I'm going to rewrite this as cosine of 5x all to the 4th power. Bring the 4 down, this is now cosine of 5x to the 3rd power. Take derivative of the inside, derivative of the inside is negative sine of 5x, and then I have one more inside to go, derivative of 5x is 5. So I'm going to pull the negative, the 4 and the 5 out, so that's negative 20. Cosine cubed of 5x times sine of 5x, and that is my y prime, my derivative. This one is sine of 3x to the 1/2 power. Bring the 1/2 down. Now that sine of 3x is all to the negative 1/2 power. Still need to take derivative of the inside. Derivative of sine of 3x is just cosine of 3x, and then I have one more inside, so that would be times 3. So that is 3/2. I've still got the cosine of 3x on top, and I had negative 1/2, so that means on the bottom inside of a root of sine of 3x. And that is my h prime of x. Part F is another chain rule. So I've got my outside function is like being raised to the 4th power. So the f prime would be 4, leave the inside alone. Now it's to the 3rd power. Now I take derivative of the inside. Derivative of the inside would be 4x minus cosine. And then you can just leave it like this. Here, very similar, y prime, bring the 3 down, x to the 5th, leave the inside alone. Now it's to the 2nd power. Now multiply by derivative of the inside, which is just 5x to the 4th. That's just 15x to the 4th times x to the 5th plus 7 squared. H, so this is actually one function multiplied by another function. So this is product rule. I'm going to call this u. You can call this one v. u prime is just 2x, v prime is derivative of cosine is negative sine of x. And now I just do u prime v plus u v prime. U prime is 2x, v is just cosine of x, plus u, which is x squared, times negative sine x. And then this is just 2x cosine minus x squared sine of x. Because multiplying by a negative is like minus that term then. We have two functions divided by one another, so I'm going to use product rule. So low is 2x minus 3, d low is then 2, high is 5x plus 2, d high is 5. And now we just plug in. Low, this one here. Derivative is going to be low, d high, 5, minus high, d low, and underneath the low squared goes. So the bottom, I'm not going to mess with that. The top, I can kind of clean up a little. So distribute this 5, that would become 10x minus 15. This would be 10x plus 4, but it's all getting subtracted, so it would be minus 10x minus 4. 10x minus 10x cancels out. Negative 15 minus 4 gives me negative 19. So this is just negative 19 over 2x minus 3 squared. And that's your derivative. One last quotient rule. So low is x, d low would then be derivative of just x is just 1. High is sine of x, and d high would then be cosine of x. So low d high minus high d low underneath the low squared goes. You cannot combine x times cosine of x. That is just x cosine of x. So it's just x cosine of x minus sine x over x squared for your g prime. Alright, number 4, we want to find the derivative and then find the derivative at pi, but first find the derivative. So this is like my x, this is just a power, so I'd bring the 2 down, that would be negative 6 theta, now to the first power. Derivative of cosine is negative sine, so negative plus, subtracting a negative would become plus sine of theta equals f prime of theta. So that's my first part, and now I want to find f prime of pi. So that's just going to be negative 6 pi plus sine of pi. So we already said in the front, but just in case you forgot, sine of pi, that's over here. Sine is your y value. You have no y value, that is just 0, so then your answer is just negative 6 pi is f prime at pi. We want to find the tangent line, so first let's find slope. Slope is from the derivative, so f prime is 4x minus 2. F prime at 1 is just 4 times 1 minus 2 is 2, so that is my slope. And then I need to find my y value, so that would be just f of 1, which is 2, 1 squared minus 2 times 1 plus 3, 2 minus 2, but plus 3 equals just 3. So then my point is 1 comma 3. And then now we just plug in. Y minus 3 equals 2 times x minus 1. Now none of my equations look like that, so I need to get y by itself. So this is just 2x minus 2. And then add the 3 over. That gives me 2x plus 1, which is C. Derivative of cosine of x times f of x. F of x is just some generic f. So this would be my product rule. U and v. U prime is negative sine, and v prime we would just call it f prime of x. So then we've got negative sine of x times f of x plus u, which is just cosine, times f prime of x. So that would be my y prime. And I can't actually take the derivative of f or put in f because I don't know what f is. 7, I want to find dy dx. Dy dx is just saying find the derivative, so I'm just asking you to find, it's the same as if I said find y prime or just find the derivative. Here I have product rule, but within product rule I've got this chain rule, so I'm going to call this u, call this whole thing v. U prime is easy, derivative of x plus 2 is just derivative of x, which is 1. Now v prime, I'm going to have to do off to the side, because v prime, I would bring this down, 3x to the 5th plus 7 now squared, and I'd still have to multiply by derivative of the inside, 5x to the 4th. So that is 15x to the 4th times x to the 5th plus 7 squared. That is my v prime. And then now I'm ready to just plug in the product rule. U prime v plus u v prime. U prime is easy, it's just 1 times v is x to the 5th plus 7 cubed plus u, x plus 2, v prime, which we just said was 15x to the 4th, x to the 5th plus 7 squared. And that is my y prime, my derivative, my dy dx. And you don't have to rearrange that, it's fine, you can just leave it like that. The values where we have a horizontal tangent line means a slope of 0, so that means f prime of x equals 0, so let's find f prime of x. This would be 3x squared minus 12x. And I want to set this equal to 0, and then now it's just factors, so I'm going to pull out a 3x, that would leave me with x minus 4. So then the values that would make each of these 0 would be when x is 0 and also when x is 4. Alright, here, finding the derivatives. So when we are adding two functions, the derivative of the f plus x is just derivative of f plus derivative of x. So a quick example would be like if I have x squared plus 3x to the 4th, right? You just take the derivative of this one and add it to the derivative of this one. You don't have to worry about any rules when they're adding or subtracting. So here, this is just going to be h prime of 2 is just going to be f prime of 2 plus g prime of 2. F prime of 2 is negative 1 plus g prime of 2 is 3 halves. Negative 1 plus 3 halves leaves me with h prime of 2 is just positive 1 half. Same with subtracting, right? It's the same rule. This would just be f prime. So take the derivative minus the other derivative equals the h prime of 3. F prime of 3 is negative 1 minus g prime of 3 is positive 1. Negative 1 minus 2, or negative 1 minus 1 is negative 2. The next h function is multiplying. So this is product rule. So I would do f prime g plus f g prime of 4 specifically. So f prime of 4 is negative 1, g of 4 is 5, plus f of 4 is 2, and this is g prime of 4 is 1. So that's negative 5 plus 2, which gives me negative 3. Here I have functions dividing, so I'd have to use my quotient rule. So low d high minus high d low. Underneath the low squared goes. So now I'm just doing it for of 2. So g of 2 is 3. F prime of 2 is negative 1. Minus f of 2 is 4. And g prime of 2 is 3 halves. Underneath g of 2, wait, no. Oh yeah, g of 2 is 3, and it gets squared. So here I've got negative 3. Negative 4 times 3 over 2, that would be 12 over, so that's just minus 6. All over 3 squared, which is 9, so that's negative 9 over 9, which is just negative 1. E, so this is chain rule. I've got a function inside this outer function. The squaring is the outer function. So I'm going to take the derivative. It's going to be 2 f of x, now to the first power, times derivative of the inside, which would be f prime of x. And specifically when x is 2, so this is just 2 f of 2 times f prime of 2. So then now we just plug in f of 2 is 4. F prime of 2 is negative 1, so this is just negative 8. Another chain rule, because I've got a function inside of a function, take the derivative of the outside, leave the inside alone, times derivative of the derivative of the inside, which would be g prime of 6. And then now we just replace, so let's start with g of 6. So g of 6 is 4. So this is f prime of that value, so f prime of 4 times g prime of 6. Now I go to f prime of 4 is negative 1, g prime of 6 is negative 2. So this is going to give me positive 2. And lastly, x times f of x. So this is product rule. So I'm going to do my u prime v plus u v prime. U prime is 1. V is just f of x plus u, which we just said was x, times f prime of x. And then I'm looking for when x is 4. So it's just f of 4 plus 4 times f prime of 4. F of 4 is 2 plus 4 times f prime of 4 is negative 1. So then 2 plus negative 4 gives me negative 2. The last one is easy. So I'm going to take this separately because this is, right, derivative. You just take this one plus derivative of this one. So let's take derivative of this first function. This is chain rule because I've got an outside function with the inside. So this is f prime of 2x plus 1 times 2 to put the inside. And then I'm going to do x and g of x over here. So this would be the u prime v plus u v prime. Derivative of x is 1, g I'm leaving alone, plus x, leave alone, derivative of g would be g prime. So, and then now I can plug in f prime of 2x plus 1, when x is 1, that's 2 times 1 plus 1, which is 3. So this is f prime of 3 times 2, plus 1, g of 1, plus 1, because x is just 1, g prime of 1. And now, f prime of 3 is negative 1 times 2, plus g of 1 is 1, plus g prime of 1 is 2. So then that cancels out and leaves me with just 1. Whew. Number 10, I've got product rule, and then this one I have to use chain rule. So I'm going to call this one my u and this one my v. So derivative of u prime is just 1. Derivative of v I'll do off to the side here, because v is 3x minus 2 to the 1/2. So I'd bring down the 1/2. This is 3x minus 2 to the negative 1/2 times derivative of the inside. So that's just 3 over 2. And then negative 1/2 means bottom in a root, 3x minus 2. So this is my v prime. And then now we're finding the derivative. So y prime is u prime 1 times v, square root of 3x minus 2, plus u, v prime, which we just said was 3 over 2 root 3x minus 2. And then now we're plugging in our x value. So 3 times 2 minus 2 is 6 minus 2, which is 4. So this is just 1 root 4, plus x value of 2 times 3 over 2 root 4. Root 4 is just 2, so 1 times 2 is 2. These 2's cancel out. 3 over root 4 is just 3 over 2. And then that gives me 3.5, so 7 over 2. So this is my slope, because that is what the y prime at 2 is. Whew. And lastly, finding the equation of the tangent line. Well, we're going to do y minus some value equals slope of this x minus the x value of 2. So then now it's just plugging in what was y, not y prime, but what was y when x is 2. So that's going to be 2 root 3 times 2 minus 2. So that's 2 root 4, which is 4. So y minus 4. And then that's your equation. Alright, derivative of a function divided by another function. So this is quotient rule. Low is 2x minus 6. D low would then be 2. High is 3x squared plus 5. D high is then 6x. So then now we just plug in. Low, D high, minus high, D low. Underneath the low squared goes. Alright, I'm going to distribute 6x times 2x is 12x squared minus 36x. And then this is just 6x squared and 10, but that negative sign gets distributed, so it's minus 6x squared and minus 10. And then 12x squared minus 6x squared is just 6x squared, and then the other ones are still there. underneath the low squared goes. So that is y prime. This one is straight power rule, but it's going to be helpful if I call this r cubed through r squared. I'm just going to say this is minus 2r to the negative 1 power. And then now I need to take my f prime, or my p prime, right? This is p of r. So p prime, just use your power rule. This is just negative 3r squared plus 4r. And then bring this negative down, that becomes a plus 2r to the negative 2 power. So this is negative 3r squared plus 4r plus 2 over r squared. And I want to find what p of 1 is, so I'm just plugging in 1. So this is negative 3 plus 4 plus 2. I can do that. Is 3. So p of 1 equals 3. And from my graph, so f over x is just quotient rule, so low of 6, d high, or low d high would be f prime, minus high, d low is g prime, underneath the low squared goes. And then now we just go to the graph. We need to find what g of 6 is, we need to find what f of 6 is, so 1, 2, 3, 4, 5, 6. This is g, so g of 6 is 2, and f of 6 is 4. And now we need to do g prime of 2 and f prime of 6, of 6. And then we can find the derivative from the graph. Well, derivative is just slope, so I just want to find the slope. So at 6, let's do g is this one. So at 6, your slope is, it's going down 4 and 2, or 2 and 1, so it's negative 2. So that was g is negative 2. The slope of at 6 is negative 2, so g prime of 6 is negative 2. And then f prime of 6, so f prime is this one. We're looking for the slope of this guy. So this one goes down 2 and 4, or you could do 1 and 2, so it's negative 1/2. And then now we plug in. G of 6 we just said was 2. F prime of 6 we just said was negative 1/2. Minus f of 6 is 4. G prime of 6 is negative 2. Over g of 6 squared, so over 2 squared. That's just 1. That becomes plus 8. Over 2 squared is 4. 1 plus 8 is 9. Oh, negative. Whew. Negative 1. So negative 1 plus 8 is 7 over 4, which is my answer. Careful with your negative signs. Here, so this would just be f prime of 1, product rule for derivative, leave the other one alone, plus leave this one alone, derivative of the other, or u prime v plus u v prime. And now I need to do the same thing, but for when x is 1. So for when x is 1, f of 1 equals 3, and also g of 1 equals 3. Derivative at 1 for g is negative 1, so g prime of 1 equals negative 1, and derivative of f is the slope. This one has a slope of 2, positive 2, because it's going up. And then now we just plug in. F prime we said was 2, g of 1 is 3, plus f of 1 is 3, and g prime of 1 is negative 1. So that's 6 minus 3, which is positive 3. Almost there. I want to know where I have a horizontal tangent line. I did this wrong on the key. So horizontal tangent line means find f of x, oh that should be f of theta, and set it equal to 0. So I take the derivative. Derivative of pi is just 0 because pi is just a number. So f prime of theta is, this one goes away, and it's 1/2. I forgot to actually take the derivative here, times negative sine of x, or of theta. So this is negative 1/2 sine of theta that I need to set equal to 0. So you can divide the negative 1/2 away, it goes away. So 0 is sine of theta. So I want to know all the thetas, all the angles between, I really messed that up, between 0 and 2 pi that make sine 0. So think about, sine is your y. Your y is 0 here and here, so that's 0, pi, and 2 pi again. So theta would be equal to, theta is equal to 0, pi, and 2 pi. Not the pi over 2 and 3 pi over 2 that I put on the key. Derivative of quotient, so low equals 3x plus 5, d low is 3, high is 5 minus 2x, d high is just the coefficient on x, so negative 2. Low, d high, minus high, d low, over low squared, gives. So this would become negative 6x minus 10, negative 15, plus negative become positive, so plus 6x. 6x and minus 6x cancel out, negative 15 and negative 10 become negative 25 over 3x plus 5 squared, and then that is your derivative of g prime of x. And then lastly, we've got our function divided, and we have the graph of g. So we're going to have to take the derivative first before we plug in our x value. So this is quotient rule, so I'm going to do low is 3x, d low is 3, high is g of 2x. So d high is chain rule because it's just g prime of 2x, but then you'd have to multiply by the 2. So then now we plug in low, d high is 2g prime of 2x, minus high, d low, and then underneath the low squared goes like this. And then now we're ready to plug in our x value of 1, so this is just 3 times 1 times 2 times g prime of 2, because 2 times 1, minus g of 2 times 1 times 3, over 3 times 1 squared. G prime of 1 is just the slope, so I need to figure out the slope. So this goes down 1, 2, 3, 4, 5, 6 in 2 seconds. That's the slope of negative 3. And then g of 2, it's g prime of 2, but it's actually the same slope. So g prime of 2 is negative 3. And then g of 2 itself, the value is 0. So then this one is going to go away because that one's just 0, and anything times 0 goes away. So this is 6, g prime of 2 is negative 3, over 3 squared, which is 9. That's negative 18 over 9, which is negative 2. Whew, we did it! This is, I forgot to actually square the 3, so I had negative 6 on my answer key, so my bad, guys.